Point 3. Continuous random variables. These are the learning outcomes for this lesson. A random variable that assumes any values contained in one or more intervals is called a continuous random variable. For discrete, we have x equal to a number. For continuous random variable, instead of a number, x is in one interval from A to B. For example, the weight of a student. Weight, we have grams, kilograms, and hundreds of kilograms. And also, we have 1 gram, 1.2 grams, 1.11 grams, and so on. Means this is a continuous numbers. The time taken to finish a race. Time is also a continuous random variables, as time can be second, minutes, hours. There is no one exact measurement for times. And the heights of a person. So heights also continuous random variables. We have centimeters, meters, inch, and so on. Means there are no one exact measurements for these variables. Examples. Indicate which of the following random variables are continuous or discrete. Life of a battery. Life of a battery means how long a battery can operate. Means we're looking for times. Times is continuous random variables. B. The number of new accounts opened at banks during a certain month. So number of accounts can be exact. 1 account, 2 accounts. There are no 1.5 accounts. So this is a discrete random variables. C. Time taken. Times is continuous. Price. Price. Again, we have ringgits and cents. So price is a continuous random variables. In other words, anything that have decimals is considered a continuous random variables. E. Total weight. Weight is a continuous random variables. Number of a student. So students is discrete. Times continuous. Height of a student is continuous. Number of rooms in a house. So number of rooms is 1 room, 2 rooms. There are no 1.5 rooms. So this is a discrete random variables. Probability density function. A continuous random variable is a random variable that assumes any value contained in real line intervals. Associated with these variables are the density function, fx, which is the equivalent to probability distribution function for discrete case. So instead of distribution function, we call continuous random variable as probability density functions. Properties of probability density function. Probability density function are with the following properties. First, we have fx greater or equal 0, means probability cannot be negative. Second, integrate from negative infinity to infinity, fx dx equal to 1, means total probability must equal to 1. Third, probability of x equal to a equal to 0. Since this is a continuous random variables, when we have x equal to a number, then the probability is always 0. 4. Probability x less than or equal a is equal to probability x less than a, means integrate from negative infinity to a fx dx. Notice that if there is equal or not equal, the limit is still the same, up to a. Last one, probability x from a to b equal to probability x between a and b equal to integration of a to b. This is the same thing as 4. Equal or does not equal doesn't matter. A and b are still the limits. Example 1. Show that fx equal to 3x squared from 0 to 1 is a probability density function for a random variable x. To show that a probability function is a random variable, we need to show total probability equal to 1. Since this is a density function, we need to integrate from 0 to 1. So, integrate from 0 to 1, function is 3x squared dx equal to 3x cubed over 3, 0 to 1. So function is x cubed 0 to 1. Substitute 1 cubed minus 0 cubed equal to 1. Shown. Example 2. Given the continuous random variable x has the following probability density function, fx equal to kx squared over 2 for x greater or equal negative 4, x less than or equal 4, and k is a constant. Show that k equal to 3 over 64. So k is in the function, and we know that since x is a random variable, so total probability must equal to 1. Total probability from negative 4 to 4, kx squared over 2 dx must equal to 1. Then integrate. K over 2 is a constant, negative 4 x squared dx equal to 1. K over 2 is x cubed over 3, negative 4 and 4 equal to 1. K, 2 times 3 is 6. K equal to 6 over 128 equal to 3 over 64. Shown. Expectation of continuous random variables. These are the learning outcomes for this lesson. Expectation of continuous random variables. The expected value of a continuous random variable x is given by 1. Mean or mu equal to expectation of x equal to total of probability x times fx. Since this is a continuous random variable, so x can take value from start of interval and up to end of intervals. Generally, x can take value from negative infinity to infinity. Second, expectation of gx equal to total of gx times fx. Third, expectation of ax plus b equal to total of ax plus b times fx. Or expectation of ax plus b equal to a times expectation of x plus b. Example 1. The random variable x has probability density function fx. A show that a equal to 4. A is in the function. The question did not mention this is a continuous random variable. Since x has probability density function, so the word density indicates that x is a continuous random variable. If x is discrete, then it has a probability distribution function. Since this is a density function, so x is a continuous random variable. So we have to integrate. And the other one that indicates this is a continuous is the interval 0 to 1. When a function has intervals, so it is a continuous random variable. If it is a discrete, then x is equal to a number. We know that total probability equal to 1, so integrate from 0 to 1, function is a x minus x cubed dx equal to 1. So a is a constant, 0 to 1, x minus x cubed dx equal to 1. Integrate. Substitute a 1 over 2 minus 1 over 4 minus 0 equal to 1. A times 1 over 4 equal to 1, so a equal to 4. Shown. B, find expectation of x. So expectation of x is integrate from 0 to 1 x times fx. Fx is 4, a equal to 4, x minus x cubed dx. Okay, x times fx. Fx is a times x minus x cubed, where a equal to 4. So x times 4, x minus x cubed. Integrate constant and integrate from 0 to 1. X times x is x squared. X times x cubed is x power of 4. Integrate. Zero to 1. 1 over 3 minus 1 over 5 minus 0 equal to 8 over 15. So expectation of x is 8 over 15. Example 2. The continuous random variable x has probability density function where fx equal to 1 over 20 x plus 3 for x greater or equal 0 and less than or equal 4. This question mentioned both continuous random variables and probability density function. So this is a continuous random variables. Find expectation of x. So expectation of x is x times total of x times fx equal to integrate from 0 to 4 x times 1 over 20 x plus 3 dx. So constant put outside and x squared plus 3x dx. Simplify function. 1 over 20 integrate from 0 to 4. Then substitute 4 cubed divided by 3 minus 3, 4 square divided by 2 minus 0 equal to 34 over 15. B, expectation of x square. Again, expectation of x square is 0 to 4, x square times 1 over 20 x plus 3 dx. So 1 over 20, 0 to 4. X squared times x is x cubed plus 3x squared dx. Integrate. Zero to 4. Then substitute. Equal to 32 over 5. C, expectation of 2x plus 5. So equal to 2ex plus 5. 2ex is 34 over 15 plus 5 equal to 143 divided by 15. And then D, ex squared plus 2x minus 3, simplify. Ex squared plus 2ex minus 3. So ex squared is 32 over 5 plus 2 times expectation of x, 34 over 15 minus 3. Answer is 119 over 15.